Namaste to all. Today we shall solve the problems based on the topic ray optics. Up to 9.15 is solved. In this class today we shall solve some more problems further. 9.16, what they ask the question is, a small pin fixed on a tabletop is viewed from above from a distance of 50 centimeter. By what distance would the pin appears to be raised? If it is viewed from the same point through a 15 centimeter thick glass slab held parallel to the table, refractive index of glass is 1.5. Does the answer depend on the location of the slab? So let us see how to solve this one. 9.16. 9.16 we are solving. From the question what they have given, upper and depth of the pin kottidara, D is equal to 15 centimeter and upper and depth of the pin actual depth of the pin D and consider madona, upper and depth here upper and depth of the pin D and actual depth of the pin we consider that one as D is equal to 15 centimeter, and let us consider apparent depth of pin D dash and refractive index of glass is equal to 1.5. So ratio of actual depth to the apparent depth is equal to the refractive index of glass and so that is calculated by D dash. So D dash and the apparent depth calculate just the formula cross multiplication ಮಾಡ್ಕೊಳ್ಳ್ರಿ. So D dash is equal to D divided by N. So D value is 15 and N value is 1.5 and we got 10 centimeter. So the distance at which pin appears to be raised calculate ಮಾಡಿರ್ತೀವಲ್ಲ. So here the distance at which pin appears to be raised. Yes, so that is given by D dash by D madadaga. So that we got 15 minus 5 madadaga ಎಷ್ಟು ಬಂತು ನಮಗೆ? So 15 minus 10 ಇದೆ. So 15 minus 10 ಮಾಡೋಣ. So how much we are getting? So that we are getting as 5 centimeter ಅಂತ ಬಂತು. So easily therefore for small angle of incidence this distance does not depend upon the location of the slab. So this is the solution for 9.16. So upper and depth in D dash and consider ಮಾಡಿವಿ. Upper and depth is calculated by using formula D divided by N. So D value they have given 15, refractive index is 1.5 and D dash value we got 10 centimeters. So by using that distance at which pin appears to be raised is calculating by taking the difference of 15 minus of 10 madadaga 5 centimeter anta bantu. So next we shall see next problem. So that is the next one. 9.17. So no rain here question So 9.17 A ಮತ್ತು B ಎರಡು question ಕೇಳಿದ್ದಾರೆ. So here the first 8th question ಏನು ಕೇಳಿದ್ದಾರೆ ಅವರು? In the figure 9.35 shows a cross section of light pipe made of a glass slab of refractive index 1.68. The outer covering of the pipe is made of material of refractive index 1.44. And what is the range of the angles of the incident ray with the axis of the pipe for which total reflection inside the pipe takes place as shown in the figure? Figure ಕೊಟ್ಟಿದ್ದಾರೆ. So B1 ಏನು ಕೇಳಿದ್ರೆ what is the answer if there is no outer covering of the pipe ಅಂತ ಕೇಳಿದಾರ. So let us see how to solve this one. 9.17. So 9.17. So from the question what they have given, ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡ್ರಿ, refractive index of glass fiber ಅನ್ನ let us consider mu1 ಅಂತ ತಗೊಳ್ಳೋಣ. So that is 1.68 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Refractive index of outer covering of the pipe ಅನ್ನ mu2 ಅಂತ ತಗೊಳ್ಳೋಣ. That is 1.44. Angle of incidence is, let us consider I, and R is the angle of refraction. Angle of incidence at the interface anna I dash anta. So refractive index of inner core minus of outer core anna simplify madidra. So that is given by mu is equal to mu2 divided by mu1. So this is also written as 1 divided by sin I dash. Or namage en beku sin I dash we have to calculate. So that is mu1 divided by mu2. So mu1 value is 1.44, mu2 value is 1.68. Have to simplify madadaga 0.857 madata. Therefore I dash is equal to 59 degree anta bantu. For the critical angle total internal reflection takes place only when angle of incidence is greater than I dash ittu anta matra agtiti. Therefore maximum angle of reflection is calculated by R maximum is equal to 90 minus of I dash madidre 90 minus of 59 madidre ಎಷ್ಟು ಬಂತು ನಮಗೆ 31 degree ಬಂತು. So let next I maximum be the maximum angle of incidence ಅಂತ ಅನ್ಕೊಂಡ್ರೆ the angle of incidence. So refractive index of A minus of glass interface calculate ಮಾಡಬೇಕಂದ್ರ so mu1 is equal to 1.68 ಅಂತ ಗೊತ್ತೈತಿ. So we have the relation for maximum angle of incidence and reflection that is given by mu1 is equal to sin I divided by sin R. So now ಏನು calculate ಮಾಡಬೇಕು? So we have to calculate sin I is equal to mu1 into sin R maximum. So here mu1 value 1.68 into sin of 31 degree. 1.68 sin of 31 under 0.5150 bantu. So even simplify madra 0.88652 bantu. Therefore I maximum value is sin inverse of 0.8652 madadaga that is almost equal to 60 degree bantu. So next nave calculate ಮಾಡಬೇಕು refractive index of outer pipe mu1 that is A for A1 ಅಂತ ತಗೊಳ್ಳೋಣ. So for the angle of incidence I is equal to 90 degree iddara we can write Snell's law at the A minus of pipe interference as sin I divided by sin R is equal to mu2 is equal to 1.68. ನಮಗೆ ಏನು ಬೇಕು sin R ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. sin R is equal to sin of 90 divided by 1.68. sin 90 value 1 divided by 1.68 ಮಾಡೋಣ. R is equal to sin inverse of 0.5952 ಮಾಡಿದಾಗ so we are getting 36.5 degree or therefore I dash is equal to 90 minus of 36.5 degree ಮಾಡಿದಾಗ, so we got 33.5 degree. Therefore, since I is greater than R, all incident ray will suffer total internal reflection of the result. So, we try to understand the method and which formula is useful and then if you understand, it is easy to solve the given problem. So next, we shall move to next problem, that is 9.18, 9.19, those are 9.18 is that is theory based. Go through that and now we shall solve 9.19. So 9.19, what they asked, 9.19. So here the image of the small electric bulb fixed on the wall of the room is to be obtained on the opposite wall 3 meters away by means of large concave lens. What is the maximum possible focal length of the lens required for the purpose? So easy way. First read the question, try to understand what they have given. Image of the small electrical bulb fixed on the wall of the room is to be obtained on opposite wall 3 meters away by means of large concave lens. What is the maximum possible focal length of the lens required for the purpose of the Kelidara? So read the question, try to write the given things and let us solve this one. 9.19. So from the question, what they have distance between object and image, let us consider d is equal to 3 meters. Maximum focal length of the convex lens F maximum antane tagolana. For real image, maximum focal length is given by the formula F maximum is equal to d divided by 4. So d value is 3 by. So d value 3 ಕೊಡ್ತಾರೆ divided by 4 and then simplify ಮಾಡಿದ್ರೆ 0.75 meter ಅಂತ ಬಂತು. Hence for required purpose the maximum focal length of the convex lens illustrated ನಮಗೆ 0.75 ಅಂತ ಬಂತು. So here very easy. So F maximum is equal to d divided by 4. D value 3 ಕೊಟ್ಟಿದ್ದಾರೆ, just substitute 3 by 4. After simplification we got 0.75 meter. This is the solution for 9.19. And let us see next one, 9.20. So what they asked the question, 9.20. So here, a screen is placed 90 meters from the object. Image of the object on the screen is formed by convex lens at two different locations, separated by 20 centimeters. Determine the focal length of the lens. So, read the question, try to understand it. They asked to find the focal length of the lens and two locations they are separated by 20 centimeters. So let us see how to solve this one, 9.20. So this is also easy one, 9.20. We are going to solve. We are solving 9.20. Here from the question, distance between image and the object in a capital D and that is 90 centimeters they have given. Distance between two locations of the convex lens and a small d and 20 centimeters they have given. Let us consider focal length of the lens is F. Focal length is related. Relation between small d and capital D is given by F is equal to d square minus of small d square divided by 4 into d. So D value 90 square minus of small d value 20 square is there, divided by 4 into d value is 90. So after simplification we are getting 770 divided by 36. So we are getting 21.39 centimeter. Focal length of the convex lens is equal to 21.39 ಅಂತ ಬರ್ತದೆ. So simple ಆಗಿ ಇದೆ, but you try to understand which formula, try to guess which formula is useful ಅನ್ನೋದನ್ನ ಏನು ಮಾಡಬೇಕು. So capital D value ಕೊಟ್ಟಿದ್ದಾರೆ, small d value ಕೊಟ್ಟಿದ್ದಾರೆ, f is equal to d square minus of small d square divided by 4d ಯೂಸ್ ಮಾಡಿಕೊಂಡು so focal length f we got 21.39. So next we shall move to next problem. So that is 9.22. So 9.22 ಏನು ಹೇಳಿದಾರೆ ನೋಡ್ರಿ. At what angle should a ray of light be incident on the face of a prism of refracting angle 60 degrees so that it just suffers total internal reflection at the outer face. Refractive index of the material of the prism is 1.52 ಅಂತ ಹೇಳಿದಾರೆ. So what they asked? So they asked at what angle should a ray of light be incident on the face of a prism of refracting angle 60 degree so that it just suffers total internal reflection at the other face. The refractive index of the material of the prism is 1.524 and the question alli kottidare. So by using given data, let us solve this one. 9.22. So here the incident, let us draw the diagram here. This is the prism. So this is the incident ray and by passing through prism. So this, if we draw the diagram, this is the angle of incidence I1 and this is R1. Angle of refraction. Let us consider prism of side ABC. So the incident reflected ray, emergent ray associated with glass prism ABC that is shown in the diagram. Angle of prism, let us consider A is equal to 60 degree. And this is the emergent ray. And here I is the incident angle, R1 is the refracted angle, R2 is the angle of incident at face A, C is the emergent angle that is 90 degree. So according to Sen's law, we are writing sin of E divided by sin R2 is equal to mu. So if you want to calculate sin R2 is equal to 1 divided by mu into sin 90. So that's equal to 1 divided by mu value is 1.524. If you simplify this one, 0.6562 we are getting. So R value, if you want to calculate, it becomes sin inverse of 0.6562. Almost it becomes 41 degree. So it is clear from the figure that angle A is equal to R1 plus of R2. So if you want to calculate R1, it becomes A minus of R2 is equal to 60 minus of 41, we are getting 19 degree. So according to Sen's law, mu is equal to sin I divided by sin R, we are getting. So here, next, if you want to calculate sin I1 is equal to mu into sin R1. So mu value is 1.524 into sin R, sin 90 is equal to, after simplification we are getting 0.496. So therefore I1 is equal to 29.75 degree. Hence angle of incidence, how much we are getting? 29.75 we are getting. 29.75. 0.75 we are getting. So it is easy, but you have to understand this one. First, draw the diagram for the reference. So angle A is 60 degree. We are using Sun's law. By using that, R2 we calculated, that is almost equal to 41. Angle A is equal to sum of R1 plus R2. So by using Sun's law, again mu is calculated, given by the formula sin I1 divided by R1. So by using that one, we calculated sin I1 is equal to mu into sin R1, or if you want to calculate I1, that value is just modify that formula, 21.75 degree we got. So next we shall move to next problem, that is 9.24 dish also. So 9.24 ಏನು ಹೇಳಿದಾರೆ ನೋಡ್ರಿ. So 9.24, the question is like this. For a normal eye, the far point is at infinite and near point of distance vision is about 25 centimeter in front of the eye. The cornea of the eye provides a converging power about 40 diopter. The least converging power of the eye lens behind the cornea is about 20 diopter. From this rough data, estimate the range of accommodation. In the bracket, they have given range of converging power of the eye lens of the normal eye length. So by using the given data, let us solve 9.24. So what they have given from the question, mean distance of the distance region, they have given D is equal to 25 centimeter. Far point of the normal eye D dash and Tuvana, let's consider that one as infinity. Converging power of the cornea PE and Tuvana 40 diopter. Least converging power of the eye lens na, so let us consider that is 20 diopter. To see the object at infinite, eye uses its least converging power. Therefore, power of the eye lens is given by P is equal to PE plus of PE. So that's equal to 40 plus of 20 is equal to power 60 diopter we are getting. So power of the eye lens is given by the formula P is equal to 1 by F. We want to calculate focal length. F is equal to 1 by P. Just modify the formula. So here from this 1 divided by 60. So here this will become, if you simplify this one, we are getting 5 by 3 centimeter. To focus the object at the near point distance, so let us consider, so that is minus of D minus that we are getting minus of 25 centimeter. Focal length of the eye lens is equal to distance between cornea and the retina, so that is equal to image distance of 3. Therefore, D is equal to 5 by 3 centimeter. According to lens formula, we are using 1 by F dash is equal to 1 by B minus of 1 by U, where F dash and the focal length. So 1 by F dash is equal to 3 by 5 plus of 1 by 25. Take the LCM of these two, 15 plus of 1 divided by 25, we are getting 16 by 25. Or if you want to calculate power, P dash is equal to 1 by F dash into 100. So this we are getting 16 by 25 into 100. If you simplify this one, we are getting 64 diopter. So power of the eye lens is calculated by using eye lens by taking the difference of 64 minus of 40. So we got 24 diopter. Therefore, range of accommodation of the eye lens is from 20 diopter to 24 diopter. So easily the D value kottidara. So they have given D value, D dash value they have given. So power is calculated by using formula 1 by F. by using lens formula. So we calculated the 1 by f dash by taking the LCM. So power calculated 64 diopter. So 64 minus of 40, we got 24 diopter. So this is the solution for 9.24. So next we shall move to next problem. So that is 9.25 is theoretical question. 9.26 we shall solve. So 9.26 in. So what they asked, the myopic person has been using spectacles of power -1 diopter for distance vision. During old age, he also need to use separate readings glass of power 2 diopter. Explain what may have happened and calculate madre. So here, focal length of the spectacle is calculated by using formula f is equal to 1 by p. So that is p value is -1. So they have given 1 diopter. So if you simplify this one, we are getting 100 centimeters. So this is the solution for 9.26. And next we shall see 9.28. So 9.28, what they asked in that A and B, 2 questions they have asked. So 9.28. So they asked 2 questions in that. So here, a man with normal eye point reads a book with a small print using magnifying glass, a thin convex lens of focal length 5 cm. In that A and B, 2 questions they ask. Eighth one, what is the closest and farthest distance at which he should keep the lens from the page so that he can read the book when viewing through the magnifying glass? B1, what is the maximum and minimum angular magnification possible using the above simple microscope? They ask. So let us see, by using given data, we shall solve 9.28. 9.28 we shall solve. 9.28. So from the question what they have given, so what is the maximum focal length of the magnifying lens they have given? F is equal to 5 cm. Least distance of the distance vision, let us consider small t is equal to 25 cm. Image distance in the B and let us consider that one as 25 cm according to lens formula. So that is written as 1 by f is equal to 1 by b minus of 1 by u. So idana modify madre 1 by u is equal to 1 by b minus of 1 by f. So b value is -25 minus of f value is 5. LCM tagiri 5 minus of 1 divided by 25 madre -6 divided by 25. So u value is -25 divided by 6 madre -4.167 centimeter 12. Hence closest distance at which person can read the book is 4.16712. So next, for the object at farthest distance, image distance in infinity and togondre. So according to lens formula, it is calculated by using formula 1 by f is equal to 1 by b dash minus of 1 by u dash. So just modify the formula, b dash in infinity and togolana, minus of 1 by 5 is equal to -1 by 5. So therefore u dash is equal to -5 centimeter. Hence farthest distance at which person can read the book is 5 centimeter. So next, maximum. So maximum angular magnification is given by the formula alpha minimum. that is given by d divided by mod of u dash is equal to 25 divided by 5. We are getting 5 ones are 5 5s are, so 5u. So maximum angular magnification we got that as 5u we got. So ಇದು ಕೂಡ ಈಸಿನೇ ಇದೆ. What we did is f value ಕೊಟ್ಟಿದ್ದಾರೆ, d value ಕೊಟ್ಟಿದ್ದಾರೆ, so v value ಕೊಟ್ಟಿದ್ದಾರೆ. By using lens formula 1 by f is equal to 1 by v minus 1 by v, we calculated u as minus 4.167 and image distance in infinity ಅಂತ ತಗೊಂಡು, so u dash we calculated minus 5 centimeter and maximum angular magnification we calculated by using lambda minimum is equal to d divided by mod of u dash. So our is equal to maximum angular magnification we got that one as 5u. So next we shall move to next question, that is 9.29. So here in question ಹೇಳಿದ್ದಾರೆ ನೋಡ್ರಿ 9.29 we are solving. In that A, B, C ಅಂತ ಮೂರು ಕ್ವೆಶ್ಚನ್ ಕೇಳಿದ್ದಾರೆ. So a card sheet divided into square each of size 1 millimeter square is being viewed at a distance of 9 centimeter through a magnifying glass. So held close to the eye. Eighth question in here, what is the magnification produced by the lens? Second one, what is the angular magnification of the lens? Third one is magnification is equal to the magnifying power. Agidre explain anta question kelidare. So let us solve 9.29. So area of each square A ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು. So they have given A is equal to area, they have given 1 millimeter square, object distance U is equal to minus 9 centimeter, focal length of the converging lens F is equal to 10 centimeter. So for image distance V, the lens formula is given by the formula 1 by F is equal to 1 by V minus of 1 by U. So F value is 10, V is kept as it is, plus of V value is 9. So after simplification, V value we got 90 centimeter. So magnification we got M is equal to, by using formula V by U, that is minus 90 divided by minus of 9. 9 ones are 9 tens are. So here 10 we got. So next we calculate ಮಾಡಬೇಕು. Area of each square in virtual image is equal to area of each square in virtual image, that is given by 10 square into A. ಎಷ್ಟು ಅಂತ ನಮಗ 10 square into 1 ಮಾಡಿದ್ರೆ 10 square ಅಂದ್ರೆ 100 ಬರುತ್ತೆ, into multiplied by 1 ಅಂದ್ರೆ 1 ಬರುತ್ತೆ. ಅದನ್ನ 1 centimeter square ಆಯ್ತು. So magnifying power of the lens is given by magnifying power of lens is given by d divided by mod of u is equal to 25 divided by 9 ಮಾಡಿದ್ರೆ 2.8 ಅಂತ ಬಂತು. Therefore magnifying is not same as magnifying power in B. And magnifying magnitude and magnifying power, the two quantities will be equal when image is formed at a linear point at 25 centimeter. So here this is the solution for 9.29. Next we shall see next question 9.30. So what they asked in 9.30 also, they asked A, B, C. At what distance should the lens be held from the figure in exercise 9.29 in order to view the square directly? with maximum possible magnifying power. P1, what is the magnification in this case? C1 is the magnifying equal to the magnifying power in this case. Explain anta keltare. So here 9.30 by using 9.29 we shall solve this one. 9.30. So here from the question what they have given, the maximum possible magnification is obtained when image is formed at near point D is equal to 25 centimeter. And next what they have given, image distance, let us consider B or minus D is equal to minus 25 centimeter. Focal length is 10 centimeter. Object distance U1 togolana according to lens formula 1 by F is equal to 1 by V minus of 1 by U. So just modify the formula 1 by U is equal to 1 by V minus of 1 by F. V value is taken minus 25 minus of F value is 10. Take the LCM of these minus 2 minus 5 divided by 50 madalaga. So that we got 7 by 50. So therefore U value we got that one as minus 50 divided by 7 is equal to minus 7.14 centimeter. So magnification is calculated by using formula. So magnification is taking mod of V by U is equal to 25 divided by 50 by 7. After simplification, we got 3.5. So magnifying power is calculated by using formula D divided by U. So that is 25 divided by 50 by 7 corresponds to 3.5. Since image is formed at near point 25 centimeter, magnifying power is equal to the magnitude of the magnification of the answer ಕೊಡಬೇಕು. So this is the solution for 9.30. So note. So by using the 1 by F is equal to 1 by V minus 1 V minus of 1 by U, by using that, so U value we calculated minus 7.14. Magnification is calculated by using formula mod of V by U, and magnifying power is calculated by using formula D divided by U. That we got 3.5. And next we shall see next problem 9. So 3.1 we shall solve. So what they ask in the question is, so note 9.31. What should be the in question ಕೇಳಿದಾರೆ ನೋಡಿ 9.31. So 9.31, what should be the distance between the object in exercise 9.30 and magnifying glass if the virtual image of each square in this figure is to have the area of 6.25 millimeter square? Would you be able to see the square distinctly with your eyes very close to the magnifier? The question ಕೇಳಿದಾರೆ. So let us see how to solve this one 9.31. So here area of the virtual image of each sphere, let us consider that one as A is equal to 6.25 millimeter square. Area of each sphere A naught is equal to 1 millimeter square. So hence magnification is calculated by taking the root of A divided by A naught. So simplify matrix 6.25 A value, A naught value 1 I think. So simplify matter 2.5 ಬರುತ್ತೆ. So magnification is calculated by image distance divided by object distance. Therefore, V is equal to M into U. So that is 2.5 into U. Let us consider this one as equation 1. So focal length of the magnifying glass F is equal to 10 centimeter. According to lens formula, 1 by F is equal to 1 by V minus of 1 by U. So 1 by Fl is 10 and 1 by 2.5 into U minus of U. Even a simplify madri, 1 by U is taken out, 1 by 2.5 minus of 1 by 1. So 1 by U is taken out in the bracket 1 minus 2.5 divided by 2.5 madri. So again the U value is minus 1.5 into 10 divided by 2.5. Simplify madadaga minus 6 centimeter, or V value is 2.5 into U. So that's equal to 2.5 into U value is 6. So we got 15 centimeter. Virtual image is formed at a distance of 15 centimeter, which is less than the near point of the normal eye. Hence, this distance can be seen by the eye distance. Distantly ಅಂತ ಆನ್ಸರ್ ಕೊಡಬೇಕು. So next we shall solve 9.34 we shall solve. to try to solve yourself, and next we shall move to 9.34. So 9.34, what they asked the question is, in that A and B and the two questions here, a small telescope, what they asked, a small telescope has an objective lens of focal length 140 centimeter and an eyepiece of focal length 5 centimeter. What is the magnifying power of the telescope for viewing distance object when the telescope is in normal adjustment when final image is at infinite? B1, the final image is formed at the least distance of the distance vision, that is 25 centimeter anta kottidare. So let us solve 9.34. So 9.34. So from the question, focal length of the objective lens, now let us consider that one as f0 is equal to 140 centimeter. Focal length of the eyepiece in fe is equal to 5 centimeter. Least distance of the distance vision d is equal to 25 centimeter. And telescope is in normal adjustment. Magnifying power is calculated by using formula f0 divided by fe. So that is 140 divided by 5, simplify 28. When final image is formed at the magnifying power of the telescope is given by the formula f0 divided by fe in the bracket 1 plus of f0 divided by d. So just substitute the values. 140 divided by 5 in the bracket 1 plus of 5 divided by 25. So 140 divided by 5 128. This is 1 plus of 5 divided by 25 is 0.2. So this is 28 into 1.2 mardaga. So we are getting 33.6 we are getting. So this is the solution for 9.34. So next we shall move to 9.35. So note 9.35 ಅಲ್ಲಿ ಎಷ್ಟು ಹೇಳಿದಾರೆ ಅವರು A, B, C ಅಂತ 3 questions ಹೇಳಿದಾರೆ. So here what they ask the question is, First, eighth one in for the telescope described in exercise 9.34, what is the separation between the objective lens and eyepiece? Eighth one, if this telescope is used to view a 100-meter tall tower 3 kilometers away, what is the height of the image of the tower formed by the objective lens? Third one, what is the height of the final image of the tower if it is formed at 25 centimeter? So let us solve this 9.35. So here from the question what they have given, so from the question they have given focal length of the objective lens f naught, they have given that is 140 centimeter. Focal length of the eyepiece is fe is equal to 5 centimeter. So therefore, in normal adjustment, separation between objective lens and eyepiece is given by f naught plus of fe, that's equal to 140 plus of 5. So this one we are getting 145 centimeter. And height they have given that is 100 meter. Distance of the tower from the telescope they have given u is equal to 3 kilometer. So if you convert into meter, it becomes 3000 meter. Angle subtended by the tower of the telescope is given by the formula theta is equal to h1 divided by u. H value is 100, u value is 3000. Simplify ಮಾಡಿದಾಗ 1/30 radian ಅಂತ ಬರುತ್ತೆ. Where h2 is the height of the image of the tower formed by the objective lens. Therefore, 1/30 is equal to h2 divided by 1/40. h2 we have to calculate 140 divided by 30 ಮಾಡಿದಾಗ, so we are getting that one as 4.7 centimeter. So next, objective lens of forms 4.7 centimeter tall image of the tower ಅಂತ answer ಕೊಡ್ತೀವಿ. Image formed at a distance of d is equal to 25 centimeter ಆದ್ರೆ magnification of the eyepiece is given by the formula n is equal to 1 plus of d divided by fe. So that's equal to 1 plus of 25 divided by 5 is equal to 1 plus of 5 raised to 6 we are getting. Therefore, height of the final image is calculated by using m into h2. So that's equal to 6 into 4.7 ಮಾಡಿದಾಗ 28.2 centimeter. So this is the solution for 9.35. So next we shall see 9.36. So what they ask the question, a Cassegrain telescope uses 2 mirrors. Such a telescope is built with a mirror 20 mm apart if the radius of the curvature of large mirror is 220 mm and small mirror is 140 mm. Where will the final image of the object at infinity be? So let us solve 9.36. So here what they have given, so they have given distance between objective mirror and secondary mirror, they have given d is equal to 20 millimeter and radius of curvature of the objective mirror na r1 anta ತಗೊಳ್ಳೋಣ. So that is 220. So what they have given, that is 220 millimeter. And focal length of the objective mirror and f1 and that is r1/2 ಮಾಡಿದಾಗ 110 millimeter. Radius of curvature of secondary mirror and r1 and that is 140 millimeter. Focal length of secondary mirror and f2 and that is r2 divided by 2 ಮಾಡಿದಾಗ, so So that we got 70 millimeter. So hence virtual object for the secondary mirror is calculated by U is equal to F1 minus of D. So that is calculated by taking the difference of 110 minus of 20 is equal to 19 millimeter. So applying the mirror formula for the secondary mirror, we can calculate the image distance by using formula 1 by V plus of 1 by U is equal to 1 by F2. So 1 by V is equal to 1 by F2 minus of 1 by U. So F2 value is 1 by 70 minus of 1 by 90 is equal to 9 minus of 7 by 630. After simplification, we got 2 divided by 630. So V value we got 630 divided by 2 is equal to 350 millimeter. So final image will be found 350 millimeter away from the secondary mirror. So next we shall solve 9.37. So 9.37 is nodri 9.37. So this is also easy one. So they asked, what they asked, light incident normally on a plane mirror attached to the galvanometer coil, we trace backwards as shown in the figure. A current in the coil produces deflection of 3.5 degree of the mirror. What is the displacement of the reflected spot of light on the screen placed 1.5 meter away ಅಂತ ಕೇಳಿದಾರ. So let us solve 9.37. So 9.37 is negative. So what they have given? So here from the question they have given angle of deflection ಕೊಟ್ಟಿದ್ದಾರೆ. So that is angle of deflection theta is equal to 3.5 degree ಐತಿ. So distance of screen from the mirror and D is equal to 1.5 meter ಕೊಟ್ಟಿದ್ದಾರೆ. Reflected ray get deflected by amount of twice angle of deflection 2 theta is equal to 7 degree ಅಂತ ಐತಿ. So therefore displacement of the reflected spot of light on the screen is calculated by using formula tan 2 theta is equal to D divided by 1.5. So D calculate ಮಾಡಬೇಕಂದ್ರೆ 1.5 into tan of 7 degree ಮಾಡ್ರಿ. So ಅವಾಗ ಎಷ್ಟು ಬಂತು? We got 0.184 meter. So that is almost equal to or 18.4 centimeter ಅಂತಾದ್ರೂ ಬರಿಬಹುದು. So the displacement of the reflected spot of light is 18.4. So next we shall move to next problem. So that is last one, 9.38. So note 9.38 what they ask is, so from the figure shows equiconvex lens in contact with liquid layer on top of plane mirror. Small needle with the tip on the principal axis is moved along the axis until its inverted image is found at the position of the needle. Distance of the needle from the lens is measured to be 45 centimeter. The liquid is removed and experiment is repeated. The new distance is measured to be 3 centimeter. What is the refractive index of the liquid anta kelidara? So just observe the diagram. So by using that, so let us solve this given problem, that is 9.38. So from the question what they have given, so they have given, so we are solving 9.38. So what they have given is, so focal length of the convex lens in the F1 and Tolana. So how much they have given? So they have given focal length 30 centimeter. Liquid act as a mirror and the focal length of the liquid in F2 and Tolana. So So focal length of the system convex lens plus of liquid and f is equal to 45 centimeter ಅಂತ ತಗೊಳ್ಳೋಣ. So for pair of optical system placed in contact, equivalent focal length is given by the formula 1 by f is equal to 1 by f1 plus of 1 by f2. So we have to calculate f2 is 1 by f2 is equal to 1 by f minus of 1 by f minus of 1 by f1. So just substitute f value is 45 minus of f1 value is 30. After simplification we are getting minus 1 by 90 andra. So f2 value how much we got? f2 is equal to 90 centimeter. So therefore let refractive index of lens mu1 anta tagondra, radius of curvature of one surface be r anta tagondra, radius of curvature of other surface r dash anta tagondra, r can be obtained using the relation 1 by f 1 is equal to mu1 minus of 1 in the bracket 1 by r plus of 1 by r dash. F value is 30 is equal to 1.5 minus of 1 in the bracket 2 divided by r. So r value calculate ಮಾಡಬೇಕಂದ್ರೆ 30 divided by 0.5 into 2 ಮಾಡಿದಾಗ so we are getting 30 centimeter. So next due to the refractive index of liquid ಅಂತ ತಗೊಂಡ್ರ radius of curvature of liquid on side of plane mirror infinity ತಗೊಳ್ಳೋಣ. So radius of curvature of liquid on side of lens r is equal to 30 ಅಂತ ತಗೊಂಡ್ರ mu2 value can be calculated by using formula 1 by f2 is equal to mu2 minus of 1 in the bracket 1 by minus of r minus of 1 by infinity. So minus of 1 divided by 90 is equal to mu2 minus of 1 in the bracket 1 by 30 minus of 1 by infinity value is 0. So therefore mu2 is equal to mu2 minus of mu2 minus of 1 is equal to 1 by 3 or mu2 is equal to 4 by 3 ಬರುತ್ತೆ ನಮಗೆ 1.33. So therefore refractive index of the liquid is ನಮಗೆ 1.33. So this is also very easy but you have to try to understand. So ಏನು ಮಾಡಿ ನಾವು so 9.38. So f1 value ಕೊಟ್ಟಾರೆ f value ಕೊಟ್ಟಾರೆ by using equivalent focal length formula we calculated f2 value is 90 centimeter and r value 1 by f1 is equal to mu1 minus of 1 in the bracket 1 by r plus of minus 1 by r is 1. R value we calculated 30 centimeter and f2 value 1 by f2 is equal to mu2 minus of 1 in the bracket 1 by minus of r minus of 1 by infinity use ಮಾಡಿಕೊಂಡು mu2 value we calculated that as 1.33. So mu r we can use n and refractive index is 1.33. This is the solution for 9.38.